Alright everybody, today's lesson is on prime factorization. I guess the first thing that we want to talk about when we're talking about prime factorization is this part of the word right here, which is factor. Alright, we need to know what a factor is. So what I'm going to do is just kind of write this down. There's our vocabulary word, factor. And I want to talk about a specific number here. So let's talk about if I'm looking at the number 16. Okay, if I'm looking at the number 16, if I'm talking about factors of the number 16, so a factor of a given number, is always going to be numbers that can be multiplied together to equal this given number. So I want to think of numbers that can be multiplied together that gives me 16. Okay, so I'm just going to start listing them here. So first thing that comes to my mind is, well, you can always do 1 times itself. So 1 times 16. So that means the numbers 1 and the number 16 are both factors of 16. Okay, so there's just 2 factors so far. Okay, now what happens is your divisibility rules come into play. So I can think, okay, well, what else can go into 16? Well, I know 16 is an even number, so that means 2 can go into 16. Well, 2 times 8 is 16, so that means that 2 and 8 are also 16. And then finally, we can probably guess one more here. 4 times 4 is also 16. Okay, so if I'm going to write factors of 16, when we write this, we usually do at least to greatest. So when I say that, that 1 and 16 are both factors, most of the time when we do this, we start by writing 1 in itself as the biggest and the smallest numbers. And I try to leave this big space in the middle so I can kind of work towards the middle here, because that's what's going to happen. After 1, then I can go up and use the 2. So that means 2 and 8 are going to be the next, smallest and biggest. And then finally I have these 4s here, but I don't have to list 4 twice. All I'm going to do is list 4 once, because 4 is a factor. I don't have to list 4 and 4. So our final answer, if we're talking about factors of 16, 1, 2, 4, 8, and 16 are all factors. Okay, they're numbers that can be multiplied together to eventually equal 16. Okay, one thing I want to point out here is this, is that factors of a number are always smaller. Factors of a number are always smaller than the number that we start with. So factors of a number are always smaller than the number we start with. So in this case, our number, the given number that we started with was the number 16 here. Okay, factors of 16 are always going to be smaller than 16. Unfortunately, that's something that I see students mess up on a lot. Is a lot of students get factors confused with multiples, because multiples get bigger. Okay, 16, 32, 48, and so on. Those are multiples. Factors always get smaller. So factors of 16, 1, 2, 4, 8, and 16. Okay, we're going to do 2 of them here. So I'm going to do example 1 for you guys here, find all factors of 24, and then I'll have you pause the video and you can try number 2 on your own. So number 1, find all factors of 24. Well, okay, so I know factors of 24 are always numbers that are going to multiply together. Oop, don't want to do that. Are always going to be numbers that can multiply together to make it equal 24. So the way I always start is by thinking, I always know every single time that 1 and itself are always going to be factors. So 1 times 24 equals 24. After that, guys, I use my divisibility rule. So I started with the number 1. Now I'm going to check for the number 2, and I'm just going to work my way up. So I want to know, does 2 go into 24? Well, my divisibility rules say that 24 is an even number. That means that, sure enough, 2 does go into 24. All right, it goes into there 12 times. 2 times 12 is what equals 24. Okay, so I did the 1, I did the 2. Now I'm going to move up and try 3. Okay, remember my divisibility rules for 24 say if I add these together, 2 plus 4 is 6, and 6 can be divided by 3. So therefore 3 works. So now I got to figure out 3 times how much. Okay, 3 times 8 gives me 24. So that works. Okay, I'm going to back up here, get rid of that stuff. So I said 3 times 8 gives me 24. So I did 1, 2, 3, and I just kind of keep working my way up the numbers here until eventually, like 3 and 8 here, eventually the numbers are going to end up being, they're going to start overlapping. Okay, so I did 1, 2, 3. I'm going to try 4. Well, does 4 go into 24? Sure. 4 times 6 equals 24. So you see the 4 and the 6, now they're getting pretty tight together here, so the only number I have left that might be between there I haven't tried yet is the number 5. Okay, well 5 doesn't go into 24 because 24 doesn't end in a 0 or a 5. Okay, so 5 doesn't work, and since now if I kept going and did 6, 7, 8, I've already tried those numbers, so now I have my final answers right there. Okay, what I'd like you guys to do is go ahead and pause the video and try example 2 on your own. Find all factors of 36. Pause the video, give it a try. Okay, should be back. Factors of 36. So again, the way I start is always with the smallest and the biggest. So I'm going to do 1 and 36, and I'm going to leave this big space in between them here so I can fill in all the numbers in between. Okay, I know 36 is an even number, so I know that 2 is going to go into it, and I might have to do some work off to the side here. Okay, if I can't think how many times does 2 go into 36, it's okay to do some of this long division. So 2 goes into 3 once. Okay, 1 left over, bring down the 6. 2 goes into 6 8 times. Okay, so that's 2 times 18. Okay, so I have the 2 written down, now I can put 18. Okay, I want to know, does 3 go into 36? Well, let's check our divisibility rules. 3 plus 6 is 9. Okay, 9 can be divided by 3. So that means that 3 is going to work. Get rid of this. That means that 3 is going to work here. Now I just have to know how many times. Again, you might have to do something off to the side. So let's do 36 divided by 3. Goes into there once. Okay, bring down the 6. Goes into 6 twice. Okay, so I end up getting 3, which is already written, and 12. Okay, I did 1, 2, 3. Let's try 4. Okay, I know off the top of my head that 4 times 9 equals 36. Okay, 1, 2, 3, 4. Let's try 5. Well, it doesn't work because 36 doesn't end in a 5 or 0, so 5 doesn't work. So I try 6. Does 6 go into 36? Absolutely. 6 times 6 is 36, and since it's 6 times 6, I know I don't have to try anymore because that's going to be the middle. So there are all of your answers, and of course we do want to rate them order from least to greatest. So the method that I'm showing you shows you a way of doing it least to greatest. Okay, now that I know what factors are, now we can get into talking about a couple of these other vocabulary. Prime numbers and composite numbers. Okay, first definition up here, okay, right up here, this one. It says prime number is any number greater than 1 that has exactly 2 factors. 1 in itself. Okay, so that's going to be something like the number 11. Okay, because if I said list all the factors for the number 11, you would start by doing this. You go, well, I know that 1 times 11 equals 11, so that's why it has 1 in itself, but 11 can't be divided by anything else. All right, only 1 and 11 works, so 11 is going to be an example of a prime number. Same thing like 19. 19 has 1 and itself as factors, but it can't be divided by anything else. So those are examples right here of what prime numbers are. Okay, prime numbers can only be divided by 1 in itself. Composite numbers then, this one here, is going to be anything else. Either numbers are prime or composite. Okay, so what I want to do is make a little chart here, which I've already started for us. Now I'm simply going to start, we're just going to do a few of these. We're going to start by just listing some numbers, like 1, 2, 3, 4, 5, and 6. Okay, and what I want us to do is go ahead and list factors of these. So let's start with the number 1. Well, number 1 only has 1 as a factor, okay, because 1 times 1 is 1, so 1 is the only factor. But according to our definition, okay, it says up here that prime numbers have to be greater than 1, right here, greater than. And again, composite numbers, it says it has to be bigger than 1. So actually 1 is one of these weird ones that it's neither one. It isn't prime and it isn't composite. Okay? Let's go on to the number 2 here. Factors of the number 2 are 1 and 2 because 1 times 2 equals 2. Since those are the only 2, that means that this is a prime number. The number 2 is a prime number. And in fact, it is the only even prime number. It's the only one that exists. Because after the number 2, when I do 4 or I do 6, sure enough, it has 1 in itself, but every other even number is going to be divisible by 2. So that's the only even prime number that there is. Okay, factors of the number 3. 1 and 3, which again makes that prime. Okay, the number 4. I have 1 and 4 as factors, but as I said, all of the even numbers now are also going to be divisible by 2, which then makes the number 4 a composite number, because as soon, I spelled that wrong, composite, because as soon as you have more than just the 1 in itself, if you get anything else, it makes it composite. The 5, 1 and 5, which makes 5 a prime number. The number 6, I have 1 and 6, but then we also have 2 and 3. So the 1 and 6 are good, that's 1 in itself, but as soon as the 2 and 3 come into play, that makes these composite numbers. And that's one thing that I'm going to ask you guys, is knowing the difference between a prime and a composite number. And you could test yourself if you want. So 5 was our last prime number here. What would be next? Okay, 7 would be a prime number. 9 is not a prime number because it's divisible by 3. 11's a prime number. 13's a prime number. 17's a prime number. 19's a prime number. 23's a prime number. And you could test yourself to see how far you could actually get. Okay, last type of question. Okay, prime factorization. So we have a couple things we learned already. One of the types of questions I'll ask is how to find a factor. I'm going to ask you how to determine between prime and composite numbers. And then this last part is going to be prime factorization. So we're going to be dealing with things that are prime, and we're going to be dealing with factors. And whenever you hear the word prime factorization, right here, factor trees are what you should be thinking about. So find the prime factorization of 36. What we're going to do is really big, start with the number 36. And what we're going to do is try to break this down into factors. So I want to try to think of two numbers that can multiply together to give me 36. And a lot of you might be thinking, okay, well, how about 6 times 6? Because 6 times 6 equals 36. And that's exactly what you need to do. I'm breaking 36 down, but it's got to be by two numbers that actually multiply together to get 36. Maybe you weren't thinking 6 and 6. You could also do 4 times 9. You could do 12 times 3. Okay, I'm choosing to do 6 times 6. Now, I want to keep factoring these things down all the way until they're prime numbers. Well, 6 is not a prime number, so I'm going to factor it down again into 2 times 3. Okay, and then this other 6, I can also factor that down into 2 times 3, because they both equal 6. And now the 2, the 3, the 2, and the 3 are all prime numbers, and that's our goal. When I get to the bottom here, I want all those things to be prime numbers. That's how I know that I'm done. Okay, so final answer now, what we need to do, okay, we always want to write these things least to greatest. So I'm going to start with the 2's, and we'll write those first, 2 times 2, and then I can write in the 3's, times 3 times 3. And I'm going to put in a little note here just to remind us, always least to greatest. Important that you do that. Always least to greatest. And then there is one more step here, and that's we want to use exponents if necessary. So if you remember back when we did exponents, if I saw a 2 times a 2 like this, I could write that as 2 to the second power, and then 3 times 3 is 3 to the second power. So that's so always least to greatest. So the 2's come before the 3's, and then exponents if possible. Exponents if possible. Okay, and that's how we get our final answer. And I can circle that, and we're done. Okay, now I want to show you real quick, what if you didn't use 6 and 6? Would we still get the same thing? Well, let's try 3 times 12, which also equals 36. Well, 3 is a prime number already, so I'm going to circle that. There's nothing else I have to do with it. But then I can factor down the 12. Well, that can become 3 times 4. Again, the 3 is prime. The 4 is not, so I got to keep breaking down anything that's not prime. Well, 4 becomes 2 times 2. Okay. Again, now, least to greatest, I would get 2 times 2 times 3 times 3, using those numbers I have circled, which you can see then is the same thing as I have here. Then, of course, I would change that to using the exponent. So even if you didn't do 6 and 6 like I did, you can use something else as long as it does multiply to get 36, and you should still get the correct answer. Okay, that's our lesson today on prime factorization, thinking factor trees.